All right. So we're going to do this one together. So again, we have a normal distribution here. I mean, it's approximately normal, as they say, but same idea. So again, what's happening here is this. We have this dog breed, and we're given that the weights, they're approximately normal. Okay? They're, normally distributed. Approximately normal. They're normally distributed with a mean of 62 pounds, and the standard deviation, we're told, is 6 pounds. Okay, so we're going to calculate some z-scores. So for instance, let's say a dog weighs 55 pounds. What is the dog's z-score? And we can also determine, is it unusual, this weight? Well, okay. So for the dog here that weighs 55 pounds, right? What do? Again, we have x here is 55. Well, let me get that laser pointer. We have x here is 55 pounds, right? We're going to convert that to a z-score. So we're going to use this formula. So we have 55 minus the mean. Again, the mean here is 62, right? Normally distributed. The standard deviation is 6, so we're dividing. So we have 55 minus 62 over 6, okay? And we get negative 7 over 6. You know, and also, again, I just calculated that in a calculator. So as a decimal, we get about negative 1.17. I think what actually happens, it's about negative 1.666, and it, never ends, it repeats. So it's negative 1.17. Now, is this unusual? Well, remember, on a previous slide, we saw that if a z-score, is between 3 and negative 3, then it's not unusual. Because again, that's basically saying that the score is within 3 standard deviations. And that can happen. That's usual, so to say. It's not rare. So it can happen. In fact, let me get back to that slide. Here it is, see? Basically, this is kind of saying the opposite where, well, excuse me, let me say it again. This is saying that if the score is below negative 3 or above 3, then that's very unlikely. So if it's between 3 and negative 3, then it is likely, and it could be, and it's not unusual. Okay, that's for the first one. This one here for 2. So here we have the dog weighs 85 pounds. What's the z-score? Well, so again, x is 85. I don't know why I have 55 there, but we have 85, okay? We just fix that. So we have 85 pounds here, okay? And again, it's just like before. We're going to subtract the mean, divide by the standard deviation. Doing so, we'll subtract, again, the mean is 62, right? That was given in the problem. The standard deviation is 6. Wait, here it is, 6 pounds. Okay. Doing so, we get 23 over 6, which is more than 3. It's about 3.83. So this is more than 3 standard deviations from the mean. In other words, the z-score is bigger than 3. In that case, the value is very unusual. It's not common. Or if it was negative 3.83, then also it would be unusual. So this dog, in other words, the weight is not a common weight for a dog of this breed. So I guess the dog is overweight, so to say. Any questions on that before I do 3? Okay. Now, what about this? We want the z-scores that correspond to 3 and -3. Well, this is actually good because this is basically telling us if a dog weighs more than this or less than this, then the dog's weight is unusual. So for 3, right, it's really just like what we saw before from the, let me see if I can get to it, this slide. It's the same. We're given the z-score, and we want the data value. Yeah. So from here, okay, we have 3 equal to this, but we want to know what x is. So I'm doing the, what do you call it, the algebra here, so to say. I like the unknown is really supposed to be on the left side of the equation. That's why I went from here to here. It's more of a logic thing, so to say. I mean, if you left it on the right side, I'm not going to take points off. I would never do that. Okay. Anyway, so what do we do? Well, it's just like before, right? We want to isolate x. We want to get x all alone. You want to determine x, right? Well, you don't want anything interfering, so you want x all alone. So we're going to multiply both sides by 6. We're clearing denominator, so we're getting rid of the denominator. That's what I'm doing here. And how is that helpful? Well, now these 6's cancel. And we get x minus 62. That's equal to 6 times 3, which is 18. 18. Okay, almost there, because now we want x all alone, so we're going to add 62 to both sides. These cancel, as you can see, and we get x equals 80. 80. So 80 has a z-score of, corresponds, to a z-score of 3. Now for -3, it's the same idea, except now we use -3. In fact, as you can see, it's really the same calculation almost. Well, the same steps, I should say. You multiply by 6, right? Because you want to get the denominator out of there, so to say. And the 6's cancel. Then we get x minus 62 is -3. Right? Again, we have z as -3. So just like with 3, we have -3 equals this. But we want to get x. So we have it equal to -3. Multiply both sides by 6 to get the denominator out of there. Then we add 62 to both sides. And we get x equals 44. So this is saying that 44 corresponds to a z-score of -3. So if a dog's weight is less than 44 or bigger than 80 pounds, right, then that dog's weight is unusual. Oh, an expected weight, so to say, is between the two. Any questions on this? Okay. All right, so I really don't want to start new stuff today. I think this will be on Thursday. So let me just stop the recording.